You notice I just put in the brackets around the sodium ion. That is a standard note. That's a typical notation for concentration. That's what it means, concentration of sodium ions. Let's get back to this. Okay, milliequivalents we are. Milliequivalents. Oh, look at that. Wait a minute here. 15. Oh, this is actually 15. Okay. Not a mistake here. This is 15. This is going to be 15. The decimal. Oh, I see where I got the decimal point. That was the previous. The one point was. I looked up the previous problem. It was 1.5 liters in the previous problem. I was looking at 1.5, and there was this 15 here. So no, this is. So this should be 55. Right? How does that look? That looks better. Um, I just made a mistake that, yeah, I just corrected it, but this is something that I see a lot when I'm grading. Well, it's probably not going to be a factor using the mastering site, but if you're working off the book, I've noticed a lot of students, this has happened quite a few times, that they would be actually do the previous problem or the next problem or use numbers from the previous problem. And I caught myself doing the same thing. So, but again, I'm trying to just work through a bunch of problems fairly quick, as if this were a quiz or an exam or something like that. So you can just see it happening. Whether this is of any value is, um, at least you'll see that I face the same challenges you do. So let's keep going and do a couple more. Ringer's solution. Ringer's solution. Okay. Na plus. Potassium plus. Okay, we got 147, 4 and 4, 147, 4 and 4. That's all milliequivalents per liter. Okay. Okay, this looks like the previous problem, and I'm just gonna, I know I haven't been talking much, I'm just letting you watch me do this. Um, Milliequivalents is just gonna be all the milliequivalents. You don't, if they ask for moles, I don't think they do that here. Um, okay, so milliequivalents, it's just gonna be these added up. Okay, 4, 4, and 147. So 147 plus 8 is gonna be, um, it's gonna be 155, no, yeah, 155 milliequivalents per liter. This is all per liter. Okay, this is still per liter, so we're in good shape. So milliequivalents uh, per liter. It's going to be 155 milliequivalents per liter. I know what I had to do for discussion boards is put this stuff up and just work through this and see if you can catch my mistakes. Because I've noticed I made a couple along the way here. I had to back up and change them. Okay, so that doesn't. Okay, I'm gonna add one more thing here. I'm gonna finish up here, but I'm gonna do something that with this 920, they could have asked you what's the concentration of chloride ion in moles per liter, and you'd have to take, well, you have sodium and potassium would be no problem, but calcium now you've got 4 milliequivalents per liter, but what's that in moles per liter? Okay, so let's do that one. Let's do that one just for fun. Okay, calcium is, let's see, calcium 2 plus here is 4 milliequivalents per liter. And you've got a charge of, you've got an equivalent is a mole of charges. So for each mole of calcium 2 plus, you've got 2 moles of calcium charges. Okay, so there's, you got 2 equivalents per mole, per 1 mole. And if you think about it, a milliequivalent, it's going to be, I'm going to give you another one. This is going to be 2 milliequivalents per 1 millimole, because a thousandth of an equivalent, a milliequivalent is going to be a thousandth of an equivalent, and a millimole is going to be a thousandth of a mole. And it's going to be pretty much the same thing. And you should be able to see too that 2 equivalents per 2 mole per 1 mole, and so forth. Remember, there's a lot of times when you're working with milli equivalents, milli anything, a lot of times, and this is kind of one where you can kind of take a shortcut and think, well, okay, if I can convert, um, if you've got milli equivalents, well, milli equivalents per liter, um, that isn't going to quite work. So you're going to need to, but those ratios here, you can kind of work with these. But okay, if we're going to do this, let's do this. Okay, 4 milliequivalents per liter is going to equal, you're going to need to go to, we're looking for, what are we looking for? I'm talking about, well, let's go to milliequivalents per liter first. We can always convert to moles per liter. You got 4 milliequivalents per liter. You have 1 millimole per 2 milliequivalents. Okay, and that's going to give you, so you're going to get that, and you're going to increase, multiply that. Now, if you want to go to moles, well, actually, I'm trying to work this problem here, so let me stop what I'm doing here, just see. Okay, 4 milliequivalents. So you've got, in other words, 2 millimoles per um, per liter. So if you want the total concentration of moles of cations, you'll have, if you wanted to convert all this into moles, it'd be no problem doing it with milliequivalents in liters for sodium and potassium and chloride because they're all single positive. But you have to change a little bit here for the. Let's see, we've got 2 moles per. Wait a minute. Let me back up. So 1 milliequivalent, 1 mole is going to give you that's going to equal 2 millimoles per liter. Yeah, 2 millimoles per liter because this is going to cancel. And you got liters here. So now you've got, you don't even have to do the calculation for sodium and potassium because there's 1 charge on each ion. So it's going to be 147 millimoles. And just set this one up just so you can see what I'm talking about. Milliequivalents per liter times 1 milliequivalent, or times, I'm sorry, times 1 millimole per 1 milliequivalent. Okay, and if you want to, let's just stick with, we can go to moles later. So these are it's going to be 147 millimoles per liter and 4 millimoles per liter here. So your total sodium ion concentration is going to be 147 millimoles per liter. That's sodium. Potassium is going to be 4 millimoles per liter. That's potassium. And calcium is going to be 2 millimoles per liter. So that's going to be what, 6? That's going to be, it looks like 153 millimoles positive ions. I said cations. So notice you've got a little bit of a difference here, and this is 147 comes from. Okay, this is, I put this up here to do that calculation, but that's gonna, right there. Sometimes if you're doing this stuff impromptu, which is what I'm doing, I'm deliberately doing it this way just so you see how I muddle my way through problems as well. It's really the same thing, the same way you do it. It's just hopefully I see things. Hopefully presumably I'm better at it, but it's solving problems is messy. Is really the point. So you have, notice you have 153 millimoles of cations in this solution, this Ringer solution, but you have 155 milliequivalent, or 155 moles per liter, millimoles per liter cations. Let's finish that up. Millimoles per liter total cation. And you have 155 milliequivalents per liter total cation. And see what one of the cautions, this is one of the cautions in working this problem. They ask, if they're just asking for milliequivalents here. They're not asking you to convert to moles. In fact, they don't do it in any of these clinical applications. But if you have, and actually they do say something about, Maintenance solution, replacement places electrolytes. They do give you, no, they give you, it's all milli equivalents in the book, but I'm just to show you that there's a difference between these, and you might run into it now and then. But uh, in this so far, they haven't asked you to convert equivalents to moles, so that's. But I just decided, well, I'm going to do some problems and let you see me work them. Okay, I'm gonna quit here, and if you go through this and you see anything, if you catch anything, let me know, or if you've got a question about it, let me know. What you're going to end up doing when you're working problems, you're not going to be able to sit down and always just do this thing in a really organized fashion. You have to be organized. You have to have the organization in your head. You have to know kind of what is going to go where. That's why you work these problems. You confront a type of problem that you've seen before, and then you know that this is how you solve the problem. You can do it pretty much the same way. So that's pretty much what I did here. That's really all I had. So um, anyway, that's it, and talk to you later.